this product is Internet Intelligence, and actually what it strives to do is to provide a view of network performance beyond your firewall. So we actually look at network performance management for the internet. So most organizations have their own data centers very well instrumented, and they'll have alerts on everything within their firewall, and they know when anything any problems are occurring in that space. But what we frequently hear from customers is that they'll receive a call from one of their customers complaining about a problem with service, and they go to look at their own data center monitoring and to assess whether or not there's a problem occurring at their end, and everything's green and they don't actually see a problem. But obviously that customer is reporting a real issue, and the question is, okay, how do you actually figure out where that problem lies between you and the customer? And obviously in the way that applications are delivered across the internet these days, there are many steps in that supply chain between you and your end customers. So that's one aspect that we look at in this application. And in order to achieve that, we allow we provide tools in the application to help build an inventory of assets. So basically, we can observe all of your network assets, and then you can save those into an inventory where we can monitor them over time. We can monitor them for routing issues or performance issues, anything that impairs the performance or delivery of service to your customers, and then we can alert you to those issues when they occur. We can email you, or we can send SMS or SNMP traps, and then we can pull you into the application and give you the tools to provide the context around the issue that you're looking at. So that's one aspect of the application. That's kind of the more operational aspect of the application. In addition to that, we provide insight into strategic questions for individuals who work for organizations who are responsible for building out infrastructure and serving new markets. And the application uses a global sensor grid to measure continuously into key global markets from a set of global data centers, and then we distinguish those measurements into those markets by individual providers, so that we can give you insight into what performance will be like if you move into a particular data center. And this is particularly useful, of course, because if you, in the absence of that, if you just move into a data center and then you encounter a problem, that's a very expensive way of finding out that perhaps that wasn't the best choice. And of course, the reality is that the internet does not respect the same geographic limitations or predictions of just looking at geographic space in a real world map. The internet is not connected everywhere. It's growing at various rates. There are some markets that are still very much in development. If you're moving into Asia or Australasia or into Africa or Latin America, you start to be exposed very quickly to the network infrastructure as it exists right now and the limitations around it. And so those things can have a significant impact on delivery into those markets. So if you're thinking of serving moving into Asia or moving into the Middle East, we can give you tools to figure out, okay, what is performance actually going to be like from various locations? What are the quirks of different providers in the path that they're using in order to deliver service into those markets? And that will enable you to have insight before you go and provision your equipment in a particular data center at an exorbitant fee and learn the hard way by selecting the wrong provider or the wrong location. So, all right. So with that, this is the what we're looking at the moment is the landing page for the application. It has a few different jumping off points that speak to some of these different threads. There's one here which is the main box in front of us is concerns troubleshooting an IP address when something goes wrong, and that leads into some operationally focused tools. And then in the upper right we have the area that looks at exploring internet performance to answer more strategic questions. Down below we have the ability to manage your assets as a collection for ongoing monitoring for performance issues, and then we have a dashboard link which takes you to a dashboard to get an overall summary of just how things are looking from that monitored perspective at this particular point. So where we're going to start right now is by looking at the performance section. Before I continue, do you have any questions?
Yes, Rob, I did. In the Internet Intelligence product here, how is it collecting the information as far as being able to view these latencies?
For the performance measurements?
Correct.
Yeah. Okay. So let's jump to the performance measurements now. I'll explain how it works as we go. Ooh, there's an example I was looking at earlier, so I'll remove that. So let me come out of that a second. So what we what we see in the performance section is we have a series of global starting points, and these are listed here. There's 132, and we're adding to them constantly. And so they represent different cities all around the globe. From each of these locations, so we can pick one here, and actually let's go back and pick that's Singapore example. From each of these locations, we measure into global routed space. So what we actually do is for a long time, we have had a history of dealing with BGP routing data, and we've been collecting BGP routing data for about 14 years actually, and we have a whole history of that going back, and that means that we can view at any particular point. We have it in real time from up to I think it's over 500 global IPv4 and IPv6 BGP sessions. From that set of routing data, we can build a real-time global routing table. So that means that we have an idea of all of the available routed space on the internet at any particular point. And that means from that global routing table, we can look at the space that is actually routed, the space that is used, and we can identify individual target IP addresses within those to represent that used space. And so what we do is build a target set that pokes into all of that routed space, and then we run that, run measurements against that target set from each of these global vantage points. So this set of 132 on the left-hand side that we see. And so as we run those measurements into that 1.5 million targets, we traverse a lot of hops along the way as well. So we hit the endpoints, that 1.5 million, but we're traversing a lot of infrastructure IP addresses. You can imagine starting from any of these points, starting from Singapore and going to a particular IP address that belongs to Twitter, or starting from London and going to that same IP address, or starting from New York and going to that same IP address. We're taking a lot of hops along the way. So we observe a few, as a result of that, we observe a few billion different hops in the course of a day. And so we have a few well, I should correct that. We have a few billion different measurements in the course of the day, and we observe many more hops as a result of that. So from all of those measurements into all of those targets, we can basically compress them, aggregate them, and come up with some overall metrics into those endpoint targets. And we can associate those endpoint targets with the organizations who route them. So we can look at the providers who are supplying, who are announcing this particular IP space on the internet, and we can use the aggregations of our measurements to give performance metrics into that particular provider. So at the moment, if we pick Singapore, as in this example, you can see that coming from Singapore, using our global targets, going to what we've identified as about 800 global markets. We can see what that aggregation of measurements looks like, and so you can kind of get an idea of overall performance. Now, in some ways, you can see that the internet does have certain geographic limitations. You can kind of see, what you would naturally expect. Points close to Singapore are green. They have better latency. We've got a legend at the bottom that identifies different latency buckets of measurements. So up to 50 milliseconds is dark green. But we can see that the ones adjacent to Singapore are predictably quite quick. But as you get away from that, you start to see the latencies increase, matching geographic space. But this also maps to where these submarine cables exist, where the connections of the internet infrastructure exist on the planet. So there are some unexpected reds in certain places, and some colors that are slightly more beige or tan than red. So you can see that Singapore has connections to the east coast. I mean, the west coast of the U.S., for example, is actually not terrible performance over that way. But obviously going across to Australia, you can see some you start to get some increase in latencies there. So does that answer your question about how we do the measurements? Because I went into a lot of detail there.
Yeah, absolutely. And so if I'm understanding you correctly, this screen here shows the reach that a Singapore data center would potentially have to the internet at large.
Yes, with a focus on particular markets. Yeah. So exactly. So if you were thinking of moving into the Asian market and you were thinking of provisioning a data center there, before you even decide to go in there, you can start to look at, okay, what would performance be like if I located a data center in Singapore, and then you could compare that to say Hong Kong. So we could pick Hong Kong. We could see the difference. In fact, why don't we do that? Let's see. And you'll see, it takes a moment to kick in, but we'll see an adjustment of speed. So you can actually see that some of the lighter greens turn dark green there. So you can get an idea of, predictably a lot of them are in China. So it depends if you're focused on delivering into the Chinese market. Hong Kong probably is a better option. Maybe that's not too surprising. But it depends what your strategy is about moving into Asia. If you're focused solely on delivering into China, then great, Hong Kong is a good solution. If you're actually looking at cost-effective ways to expand more generally into Asia without having to have multiple data centers, one in Hong Kong, one in Singapore, and then one in India, it's like this would allow you to figure out whether or not you can get away with less as well. Whether or not there are ways that you can not just do the obvious and drop a data center into every single market, but actually, what's the minimum cost, for provisioning data centers as well. But yeah, one of the things that we have on the left-hand side here is we have our global vantage points, which are basically Dyn collectors distributed around the globe. You also have the ability to set up your own collector in your own data center to get more accurate measurements from your data center to these markets globally, and that can give you insight into how well you're performing right now. It helps with when we're monitoring to try and identify some of the performance issues that you may be experiencing, or as we look at the measurements over time, whether or not there's impairment on a particular day or at a particular hour, something occurring right now. And it also allows you to, by provisioning the collector in different data centers that you own and operate, it allows you to explore what failover strategies would actually look like. So if you have 5 global data centers and you don't necessarily want to provision a backup in Hong Kong in case Hong Kong goes down. You instead want to introduce a policy of falling back to maybe Los Angeles or Palo Alto. You can use this data to kind of get an idea of what that experience would be like for your end customers, and whether or not that's effective for the kind of content you're delivering, or whether or not you're going to just you will need to provision something closer to the market. So, any other questions?
So, is there other metrics that I can look at in Internet Intelligence when I'm trying to strategically decide on where to place data centers throughout the map?
Yeah. So actually, I've barely started on looking at the provisioning a data center here. This gives you an overall view of delivery into a global market. We can, this aggregates up all of the measurements to an individual city. But if you're looking at delivering to a particular marketplace, say, we were looking at, how best do I deliver into Australia or something, we can get it. We can click on that city. We can start to see some of the different providers. We actually have a global ranking that we maintain, and we have a different product, IP. TI, which actually shows global rankings of providers for different markets, but we utilize that same data here to rank providers and associate latencies with them. So you can get an idea of the different providers in Perth, for example, or how well you could serve Sydney. You can compare those providers, all the major ones are there. We can drill in to see how well those providers have been performing over time. So by default, this is a 7-day view, and what you're seeing is the top 5 providers selected by default, shown over time. So we can adjust that view to answer strategic questions to, say, the last 3 months, and we can look back at the last 3 months and see, okay, just how do these providers compare when going between Singapore and Sydney? If we don't like the providers that we've selected here, say we get rid of M2, we could select a replacement provider if there's one that you're considering to use in a particular market. We could pick PACnet, or what else have we got here? There's a Telstra Global. Actually, let's pick Telstra Global. So you can pick that, and you can get an idea of what the experience would have been like. It actually looks as though, when we look at this 3-month view, we're just looking at performance latencies over a longer period, but you start to get an idea of how stable the service is likely to be for your customers over time. And we can see that Telstra quite clearly looks like a pretty flat line, while NTT, even the Telstra Global line, right, and this Microplex line, all experiencing various bobbles at various points, and you can see that they're increasing from 100 millisecond latencies up to 250. So quite significant shifts there actually in performance. So Telstra's pretty good. One thing we also show is the variability around each of these providers and the measurements we're taking for them, so we can get an idea of how consistent their performance is. So if we select the variability for Telstra, you can see there's a little shadow here. You can see that it shows, on that particular day, latencies did deteriorate on those over a couple of days here in June. But you can get an idea of how variable the experience is for each of the providers, and use that as another metric when considering which provider to select to use, or to serve a particular market. In addition to that, we can also, NTT is kind of, so NTT doesn't come out of this one looking very good. But yeah, so in answer to your question, really we're looking at latency measurements over time taken from traceroute data, and then we're looking at some of the, we're looking at the median, which is calculated for thick line, and then we're actually looking at the upper and lower quartiles. So we're looking at the 25th and 75th percentile range to kind of get an idea of the spread of measurements during the course of a day. And those are the primary metrics that are used in this area. We are, well, anyway, I'll continue. So does that answer your question there about additional metrics, or did you have anything else you were poking at?
Yeah, absolutely. I did have a couple of follow-up questions. If I am using multiple providers to a specific market, can I use this information to kind of decide what provider I should be routing over on specific times of the day? Does it get as granular as that?
Yes, it can actually. So yes, it would. At the moment we're looking at the last 3 months. If we look at one of these providers, and actually it's a pretty obscure link. It should be a lot clearer, and I apologize for that. But there's a little link here which identifies the path. But actually hidden behind this is a bunch more data, and I think it needs to be made more obvious in the product. But anyway, so if I click that, we jump through to see the paths we have observed over the last 24 hours. And it's taking a little while to load, so we'll wait for that. So yeah, so we can see, not just that aggregation up for a provider in a particular market, but we can identify the individual paths that we've traversed in the course of the last 24 hours. We can see that 25% of the time, this path here that goes via Adelaide and Melbourne, which got a little bit of bouncing around, is used. And that particular path has a latency of 147 milliseconds. We see that 14% of the time we're seeing this second path here that includes an MPLS tunnel, which is identified by this little tunnel icon here, that goes via Tokyo, and has 189 milliseconds associated with it. If we click to see more paths at the bottom of this section, we can jump down and we can see, oh, look, here's one actually that has 250 milliseconds associated with it. So 10% of the time we're hitting this 250 millisecond one. In fact, there's another one now with 4% of the time. So 14% of the time we're actually hitting 250 milliseconds, for a particular path by comparison to 147 milliseconds. So at some points during the day, your customers, if you would serve using these providers coming out of this data center, and going through these upstream paths, your customers could experience this kind of bobbling. And actually, you can see the reason for this is that this particular path is going from Singapore across to LA before coming back to Sydney. So actually, this is another one of those things where you see the quirks of the internet infrastructure. So you see that coming from Sydney, the clearest geographic path would obviously be to come straight down to Western Australia. But actually, what's happening because of how this particular provider, NTT, is managing their own costs and load balancing their own traffic, is they're hairpinning off the West Coast and then bringing it back that way, and that's impacting anyone whose service is delivered through NTT into that market by impacting them 14% of the time by increasing latencies twofold. So that can have a real impact depending on the kind of service you're delivering. And more granular still, we can use this second tab to jump and look at the measurements that we've taken over the last 24 hours up to the last 10 minutes, 10 to 15 minutes. And so this gives us an idea of, gives you an idea of where that median latency is coming from, where all the measurements are coming from. This is really, as granular as we get. We've identified the path, so now we're identifying each of the individual measurements that we're taking into NTT from that particular location over the last 24 hours. And this has, this can give you an idea of the confidence you can have in the measurements you're seeing. With some of these bigger providers, there'll be a ton of measurements during the course of a day, It'll also give you an idea of whether or not there are multiple modes that occur during the course of the day that maybe are associated with these different paths. In fact, we can see, we can see that 250 millisecond path that goes off LA up here as a kind of the upper line, and then we have our more direct service down here. So that's something that you could, potentially raise with NTT if you were buying service from them in that market. You could lean on them to say, hey, incidentally, can you send me the shortest route, the quickest route, and not use that other one. I know it's convenient for you, but actually it's not great for me, and I'm paying you. So you can use that information to kind of lean on providers. And where was I going? I think that's it. So in terms of more granularity, that's about as detailed as we get at this point. We do have some other things that we're looking at adding into the product in the future, which would allow you to, select a range, say this section up here, and kind of more clearly identify the path associated with it. But that's about as detailed as we get. We're trying to span that region from, giving that, what if scenario for high-level strategy that looks back over 3 months, down to this kind of view, which is more operational in focus. And obviously, if you were troubleshooting a particular problem which was coming to you from your customers in Australia, behind NTT, and you were trying to figure out what that problem was or how universal it was, and trying to contextualize the complaints that you're getting, into your customer support, you could use this tool to kind of see whether there are any bubbles, any particular deteriorations in performance associated with NTT in Sydney over the last 24 hours, so you can get an idea if something's actually happening right now to aid with the troubleshooting part.
Now, in regards to latency, is there any way for me to set up alarms if latency exceeds a certain value, so that I am notified as soon as that metric has been exceeded?
Yeah, absolutely. There are a couple of different things that we look at in terms of performance alerts. One of the things that we can do is we can search for a particular organization. So we can look at Wells Fargo or something, and take a moment to load. But what we see in the search results are all of the network assets that we identify as belonging to Wells Fargo. So we see on the right-hand side some obvious domains that are owned by Wells Fargo. On the left-hand side, we see prefixes and ASN, so autonomous systems that belong to Wells Fargo. And there's an awful lot of them over here. So we can see, there's a ton of stuff. It's located in different places in India, stuff that's dedicated to different functions or associated with particular verticals for Wells Fargo. You can also use this stuff to kind of identify acquisitions that Wells Fargo has done, but it allows someone who's working for Wells Fargo to actually collect all of that information, kind of manage it, and understand what it is that they need to absorb into their network. So you can get all that stuff. You can click on the link to add it to a portfolio, and in the spirit of his one I created earlier, we've got one. If I click and go to the inventories list, I can see the sets of networks that I've set up already, and here's one for Wells Fargo. I've got 3 in here, and I'm monitoring all 3. Netflix isn't currently experiencing any issues, but I'm monitoring them over time. So if we look at the Wells Fargo one, it takes a moment to load. A little longer than a moment. So while we're waiting, so if I look at the Wells Fargo one, what we're going to see is monitoring. The monitoring that's implemented in the applications at the moment, it just covers routing issues. So we're just looking at routing issues at this point, and what we're adding in the coming weeks will be performance issues as well. So we could look at performance issues that we are identifying from those trace route measurements into these Wells Fargo networks, and we can identify exactly as you were describing, impairment that we see, so deterioration in terms of increases in latency or failure of trace routes to hit the end targets when typically they do. So we can look at the behavior over time, identify that this thing usually responds, but right now it's not, and it hasn't been for the last 30 minutes, so here's an alert, or the last 5 minutes or 15, whichever would be most useful. So so what we're seeing at the moment is some of that monitoring. What you can see is that this particular network, this /19, has is experiencing an outage. So we can look at that network and see what the outage is. Actually, in this case, I think I set this up earlier today, and actually it looks as though it's actually just being announced by Wells Fargo themselves. So it's not, strictly speaking, it's not a hijack. So I would have to approve this AS as an acceptable origin for this prefix. But if we go back, we can see subnet hijack, so we can see additional, more specific networks that have been announced underneath this /14, for example. So this /24 has been announced by Windstream. Probably normal, probably Wells Fargo. If either of us worked at Wells Fargo, we would know whether or not Windstream is one of our providers, and we'd be able to identify that and assess whether or not that's a real threat or not. So we collect a bunch of different routing issues on this page as part of our monitoring. There's hijacks, more specific network announcements, outages where the network actually just gets withdrawn completely, and then instability, which is kind of like flapping, where the network is announced and withdrawn rapidly for a period of time, which would, of course, affect connectivity. So we announced that one as well. In the coming weeks, we're going to be adding, as well as the performance alarms that we're adding in here, we're also adding in ASN alarms and also some unexpected activity alarms, which is actually for networks that you own but you've parked and you don't actually expect to see announced on the internet at any point. Maybe you're saving them for your future expansion into Asia, for example, and you set them aside and they're earmarked for that, but you don't expect to see them routed at all. We can alert you if someone actually makes a mistake and announces them prematurely or anything. So that's. Does that answer your question about monitoring?
Yeah, absolutely. So with this monitoring, you could very effectively tell if the outage is actually related to my network or if it's further down the line. Is that correct?
This would pinpoint, this particular monitoring right here that we're looking at is to do with routing. So it's really looking at, the availability of your routes as they connect to the internet. So it's, is the route available? Is that space reachable through your provider? Is it reachable through your autonomous system? And is there anything odd about those providers or the announcements of those networks? As we add, performance alarms, which looks at the trace route data, then we'll be more effectively alerting on, shifts in latency or failure to reach a particular target. And for those examples, the path becomes more granular, and we can pinpoint exactly where that failure is occurring or where that impairment is occurring along the path. So that's not so visible in the routing alarms that we're seeing right here, but it is visible as we were looking at. We spent a lot of time looking at the performance part of this application. When those alarms come, that same granularity will be available to actually pinpoint some of those issues. I can go into the troubleshooting section to kind of explain some of that part, but I noticed that we are running close to time, so we can leave that for another time if you want, or I can attempt to cover it quickly. That would help explain some of this, but yeah.
Sure, we can definitely take a brief look at that.
Okay. So if something does occur, so if we're monitoring all your assets over time and an issue does occur, we can look at that particular network and troubleshoot it. So we have a troubleshoot link, or I can look at a particular network. I can start with a domain we're all familiar with, and is increasingly important to various organizations in terms of managing their brand and delivering to customers. So we look at Twitter. We can get an idea of where that's hosted globally. We can look at the individual IP addresses that we see announced. We can look at the domains associated with them. So we see those domains on the right side. You can see there's a lot of variations associated with particular IP addresses. If we go up, we can see obviously they use Edgecast for some CDN association. We can look at some of these networks that are routed that look like they're in San Francisco, and most of their data center seems to come out of San Francisco. So you can, at the moment, what we're looking at is a view of how this connects to the internet in terms of that routing data. So we see that this IP address that's associated with our Twitter domains is routed through this /22 prefix, which gets announced by Twitter's own autonomous system globally, and then Twitter is very well connected. It has a diverse set of providers. If there was only one here, and say it was only NTT, and something happened to NTT, then it means that would affect Twitter as a whole. So they would need a backup provider to ensure that they have multiple connections to the internet, so they're not vulnerable to upstream issues like that. And we can also see various peering relationships. We can use troubleshooting into this network by what we can actually do is I can click connectivity. We can use our global infrastructure to measure to the target on demand. So we can actually use that global structure, run traces from it right now. They get passed out to all of those various locations, and then they measure into this target. So we can look at this Twitter address. And one of the things that you can see coming up is that successful connections come through as blue dots, and unresponsive ones come through as gray. So what you identify is that there are some gray ones here in China, and we can see that in fact if we click on one of those cities like Zhengzhou or Beijing, we can see that we're starting at our Beijing collector and we are stopping in Beijing, and then we're becoming unresponsive. So Shanghai has the same. We're only getting as far as China Telecom. And that means that Twitter.com is actually, or that particular IP address is being blocked in China, so you can kind of get an idea of when you use this for your own service, your own IP addresses, you can get an idea of where you may be vulnerable to, geopolitical issues at a particular time, or, in that increasingly balkanized internet, where you are actually experiencing balkanization. And so we can look at those. We can look at the individual paths to those. We can jump to the connectivity analysis section, and what you see here is basically a summary of all those paths from all of those global points. What you see is this sunburst, we call it, actually has the target in the center. So the target IP address we're saying is in San Francisco. So we've got this bubble corresponds to the target of this sunburst on the right-hand side. If I zoom out at each of the outer points, each of the outer points represents one of our starting cities. So we can see Armenia, we can see Pakistan, we can see Seoul, and you get an idea of what the hops are coming from Seoul through SK Broadband to reach Twitter. So we can see at some point here we pass into San Francisco, and we can identify individual routers. We can identify key infrastructure routers that deliver that are significant in the delivery of this particular service to large swathes of the globe. So you can identify, in the case of a failure where you're getting an eclectic set of calls from a diverse set of customers, who seem to share no geographic association, you can figure out in fact, the reason they're all calling is because of a failed router, and you can pinpoint that router because you'd be able to associate it here. So you can see there's kind of dependencies. And then finally, we can look at latencies that, from the measurements we just took into this particular target, and you can get an idea of whether or not there's a particular spike or deterioration of latencies at the moment. Now, actually, looking at this, the dark green means that this is probably a geolocation error, and this is probably on the east coast of the U.S. and not in San Francisco. So it's probably hosted over here. Looking at that. Okay, and so that's a troubleshooting section, but it also gives you an idea of paths. It will also allow you to pinpoint where on the internet on one of those paths a particular problem is occurring, and of course it gives you insight into some of those brand management challenges that organizations have these days as well. So I think I've probably run out of time. Any questions?
No, I think that was a great demonstration of the product.
Okay, excellent. Thank you.